All right, listen up. The grid goes down. The power company laughs at your unpaid bills. You're sitting in the dark, wondering how you're going to charge your phone to doom scroll through the apocalypse. What do? You build a wind turbine out of garbage. That's what today we're turning trash into electricity, specifically plastic bottles and old computer fans into a legitimate power-generating wind turbine. Will it power your house? Absolutely not. Will it charge a phone or run some LEDs during a blackout? You bet your recycling bin it will. Before we get started, check out the link in the description to download our ebook. Check out our merch, brand new Christmas stock. Use the discount code YouTube. Link in the description. Now let's get back to the video. Grab your junk drawer, raid your neighbor's trash if you have to, and let's get building. Before we start, quick safety moment. We're dealing with electricity here, which, fun fact, can absolutely ruin your day. We're also cutting plastic and metal, which means sharp edges that will slice you faster than you can say tetanus shot. Wear gloves when handling cut materials. Don't lick the wires. And for the love of all that is holy, do not connect this thing to your house's electrical system unless you want to meet your local fire marshal personally. We're staying low voltage. We're staying safe. We're staying out of the emergency room. Got it? Good. Here's your shopping list. And by shopping list, I mean scavenging list. First, you need a DC motor or a computer fan. The 12-volt variety works best. You know those old desktop towers collecting dust in your garage? Rip one open. Inside, you'll find at least 2 or 3 fans. Congratulations, you just found your generator. Next, plastic bottles. 2-liter soda bottles work perfectly. You'll need at least 1, maybe 2 if you want to experiment with blade size. The thicker the plastic, the better. We're not making art here. We're making blades that won't disintegrate in a stiff breeze. You'll also need wire, any kind. Speaker wire, old phone chargers, lamp cords. If it conducts electricity, we can use it. You'll want about 2 meters, give or take. For mounting, get creative. PVC pipe works great. Wood dowels, old broom handles, even a sturdy cardboard tube from a roll of wrapping paper. We just need something to hold this whole contraption together. Fasteners, screws, bolts, hot glue, zip ties, duct tape, super glue, the blood of your enemies, whatever you've got. This is a no judgment zone. And finally, something to test your output. A multimeter if you're fancy, or just an LED light if you're not. We need to know if this thing actually works. Quick science moment, a computer fan is basically a motor with blades attached. When you spin those blades with electricity, they move air. But here's the magic. If you spin the motor manually, it generates electricity. It's reverse engineering at its finest. So our plan is simple. We attach bigger, better blades to that motor. The wind spins the blades spin the motor. The motor generates power. We are literally stealing energy from the sky. Take that, physics. Let's start with the fan. If you're pulling it from a computer, you'll need a screwdriver. Open up that case and locate the fans. There's usually one in the back, one on top of the processor, maybe one on the power supply. We want the biggest one you can find. Unscrew it carefully. You'll see 2 wires coming out, usually red and black. Red is positive, black is negative. Do not cut these wires too short. You'll hate yourself later when you're trying to connect things. Leave at least 15 centimeters of wire attached. Now here's a pro tip. Before you remove that fan, spin it with your finger. Feel that resistance. That little bit of friction, that's actually a good thing. It means the motor has magnets inside, which means it'll generate better voltage. If it spins completely free with 0 resistance, it's going to be a weak generator. Still usable, but weak. This is where the bottle comes in. Take your 2-liter bottle and remove the label. We're going to turn this into helicopter blades, except way less safe and way more janky. Cut off the bottom of the bottle about 5 centimeters up. Set that aside. Now cut off the top, where it starts to curve into the cap, about 7 centimeters down. You're left with a cylinder. Here's where it gets fun. Cut that cylinder lengthwise so you have a flat sheet of plastic. Now mark out your blades. For a standard computer fan, for blades work best, draw 4 rectangles, each about 10 centimeters long and 4 centimeters wide. Cut them out. You now have 4 plastic rectangles that look absolutely useless. Don't worry, we're about to make them aerodynamic. Take each blade and cut one corner at an angle, like you're making a crude trapezoid. This angled edge is what's going to catch the wind. The sharper the angle, the faster it'll spin, but also the more unstable it'll be. Aim for about 30 degrees. You're not doing trigonometry here, just eyeball it. Now, and this is important, twist each blade slightly along its length. Not a full pretzel twist, just a gentle curve. This creates pitch, which helps the blade grab air more efficiently. Think of airplane propellers. Same concept, worse execution. Remember those original fan blades on your motor? We need to remove those. Most computer fans have blades that just pop off if you pry them gently. Some are screwed on, some are glued. If they're glued, get aggressive. Pliers, heat from a lighter, pure determination. Just don't break the motor shaft. Once those blades are off, you'll see the center hub. This is where we're attaching our new blades. If you're lucky, there are screw holes. If you're unlucky, we're using hot glue and prayer. Space your 4 blades evenly around the hub, 90 degrees apart. Use a marker to mark the positions first, then attach them one at a time. Hot glue works surprisingly well for this. Glob it on thick. We're not winning design awards. We're building a functional turbine out of trash. If you want extra security, wrap each blade base with a zip tie pulled tight against the hub. You can also drill small holes through the plastic and wire them down. But that requires a drill, and we're keeping this low-tech. Let the glue dry completely. I know you're excited. I know you want to test it immediately. Don't. Give it 20 minutes. Go make a sandwich. Hydrate, stretch. We're patient builders here. While that's drying, let's talk about wiring. Remember those 2 wires from the fan, red and black? We need to extend those and add a way to connect to our battery or device. Strip about 2 centimeters of insulation off the ends. If you're using a multimeter to test, you can connect directly to those. If you're charging something, you'll want to add a connector. Old USB cables work great. Cut off the device end, strip the wires, and you'll find 4 tiny wires inside. You only need 2. Red and black, power and ground. Twist the red fan wire to the red USB wire. Twist the black fan wire to the black USB wire. Cover each connection with electrical tape or heat shrink tubing if you're fancy. This prevents shorts, which prevent fires, which prevents sad times. If you don't have a USB cable, you can also connect directly to a rechargeable battery. Just match positive to positive, negative to negative. But be careful, if you hook it up backwards, you won't generate power. You'll just make the blades spin the wrong direction and feel foolish. Your turbine needs to face the wind, which means we need a mount that allows it to pivot. This is where that PVC pipe or dowel comes in. Take a piece about 30 centimeters long, attach your motor to one end. You can zip tie it, screw it if there are mounting holes, or hot glue it if you're feeling reckless. Make sure it's secure. If this thing falls apart in the wind, you just wasted an afternoon and a perfectly good bottle. The other end needs weight for stability. If you're using this indoors for testing with a box fan, you can skip this. But if you're mounting it outside, wrap some duct tape around the bottom end and embed some washers, nuts, or small rocks. We need counterweight so the whole thing doesn't topple over. For outdoor use, you'll also want a base. An old flower pot filled with dirt or sand works great. Stick your dowel in there and pack it tight. Alternatively, screw or clamp your mount to a fence post, balcony railing, or any vertical surface that faces prevailing winds. Moment of truth. Take your creation outside or position it in front of a strong fan. Connect your multimeter to the wires, set it to DC voltage, and watch the readout. Give those blades a spin manually first. You should see the voltage jump. Even a weak spin should give you half a volt. A strong spin might give you 3 to 6 volts. If you're getting double digits, congratulations, you've built something genuinely impressive from garbage. Now let the wind or fan do the work. The blades should start spinning on their own. If they don't, your blades might not have enough pitch. Go back and twist them more aggressively. If they spin but generate almost no power, your motor might be weak or your blades might be too heavy. For charging a phone, you ideally want at least 5 volts consistently. For running LEDs, you can get away with 2 or 3. Test different wind speeds. Test different angles. This is the fun part. This is where you optimize. Want more power? Here are some pro tips. First, blade size matters. Bigger blades catch more wind, but require more force to spin. If you're in a low wind area, keep them smaller. If you've got steady, strong winds, go bigger. Experiment. Second, weight is your enemy. Every gram of extra weight on those blades means more wind needed to spin them. Trim excess plastic. Drill holes in non-critical areas. Make them as light as possible without sacrificing structural integrity. Third, reduce friction. Put a tiny drop of oil on the motor shaft where it enters the housing. Not too much, or it'll spray everywhere. Just enough to make it spin smoother. You'll gain significant efficiency. Fourth, add a tail fin for outdoor use. Cut another piece of bottle plastic into a rectangle about 15 centimeters long. Attach it perpendicular to your mount on the back end. This acts like a weather vane, keeping your turbine pointed into the wind automatically. Genius. Fifth, consider gearing. If you have old gears from toys or bikes, you can create a gearing system that spins your motor faster than your blades are actually turning. This multiplies your output voltage. It's complicated but effective. Let's be honest, this thing is held together with hope and hot glue, but we can make it last longer. First, weatherproofing. If you're using this outside, coat all electrical connections in hot glue or liquid electrical tape. Water and electricity are not friends. Second, reinforce the blade connections. After a few hours of use, check them. If any are loosening, add more glue or another zip tie. Wind stress is real. Third, protect the motor. Computer fans are designed for weather. If you're mounting this permanently outside, build a small housing around the motor. Cut a bottle in half and hot glue it over the back of the motor, leaving the shaft and blades exposed. Instant rain shield. Fourth, secure your wiring. Use zip ties or tape to attach the wires along your mount. Loose wires flapping in the wind will eventually break or disconnect. Keep everything tight and organized. Fifth, periodic maintenance. Every few weeks, check all connections, roil the motor shaft, and inspect the blades for cracks. Plastic degrades in sunlight. If a blade starts to crack, replace it before it fails catastrophically and takes out your whole turbine. So what can you actually do with this? Let's be realistic. You're not going off-grid with a bottle turbine, but here's what you can do. Charge phones slowly. In good wind, you might get a full charge in 6 to 8 hours. Not fast, but free. Run LED lights. A small string of LEDs draws almost no power. This turbine can keep them lit all night. Power small electronics, portable radios, small fans, anything that runs on 5 volts or less. You can also use this as a battery maintainer, connected to a rechargeable battery with a charge controller in between. The turbine charges the battery during the day, you use the battery at night. Boom! You've created a complete off-grid power system for under $10. And honestly, even if you never use it practically, you've learned about energy generation, motor mechanics, and aerodynamics. Plus, you've got an excellent conversation piece. Nothing says prepared like a wind turbine made from a Coke bottle. Blades won't spin. Check the pitch. They need to be angled to catch wind. If they're flat, they'll just vibrate. Spins, but no power. Your connections might be loose or backwards. Double-check polarity. Red to red, black to black. Power is inconsistent. Wind is inconsistent. Add a battery to the system to smooth out the output. Blades broke. Use thicker plastic or reinforce with tape along the edges. Motor making weird noises. You probably have debris in the bearings, or you over-oiled it. Take it apart and clean it. Whole thing fell over. Add more weight to the base or improve your mounting. Physics is unforgiving. And there you have it. You just built a functional wind turbine from materials most people throw away. Is it going to save the world? Probably not. Is it going to save your phone battery during a camping trip? Absolutely. The beauty of this project is that it scales. You can build 10 of these and wire them in series for more voltage or in parallel for more current. You can mount them on your roof, your balcony, or strap them to your backpack while hiking for the most ridiculous portable charger ever conceived. More importantly, you've learned that generating electricity isn't magic. It's just magnets, wire, and things that spin. And once you understand that, you realize that power isn't something you have to buy from a company. It's something you can literally pull out of thin air with garbage and determination. So, go build your turbine, experiment, break things, learn. And when the apocalypse comes and everyone's staring at their dead phones in despair, you'll be over there smugly charging yours with a Sprite bottle and a breeze. If you built one of these, drop a comment below with your results. What worked, what failed spectacularly, and how much voltage you're getting. And if you're feeling generous, hit that subscribe button. We've got more Garbage to Glory projects coming your way. Now get out there and harness some wind. I'll see you in the next one.